Today we're going to continue our discussion on angles and trigonometry on angles. The angles now that we did the last time were angles in a right triangle. And angles in a right triangle can never get larger. They can't even equal 90, all right? So we were talking about angles between 0 and 90, not including 0 and 90. Today, we're going to expand upon that, and you're going to be able to do trig functions of all kinds of angles. So let's get started. Before we actually do, don't forget the relationships between the sides on our special right triangles. Here's a 45, 45, 90. The side relationship is, 1, 1, root 2. In other words, the hypotenuse is root 2 times the leg. So 1, 1, root 2. Remember, a 30, 60, 90 relationship is 1, 2, hypotenuse twice the little leg, and the longer leg is root 3. So it's 1, 2, root 3, 1, 1, root 2. Okay? Now, you might say, okay, big deal. I'm just going to punch it into my calculator. Like, for instance, if you want the sine of 60, yeah, you can punch sine of 60 in your calculator. I'm not going to fight you on that. You're going to get 0.866. On a test, if I ask you for the exact value, 0.866 is not going to cut it. I want the exact value. The exact value would be root 3 over 2. Okay, that's the exact value. If you divide root 3 by 2, you do get rounded off to 0.866. Okay, but watch out. If I ask you for exact values, that's what I will want. And it's very helpful to know these relationships. All right, so let's talk about sine, cosine, and tangent of angles bigger than 90 degrees. Now, we talked already, when you want to draw an angle, you always start on the positive x-axis. We're going to go 120. This in one quadrant would be 90. So we're over here a little bit past 90. And then you draw a right triangle, okay? This is called the reference angle down here. If this is 120, then we know this total is 180. This angle down here would be 60, okay? So that little guy down there is 60. The reference angle is 60, and that's what we will use to get our sine, cosine, and tangent, okay? You know, for a 30, 60, 90 triangle, you know the little side is 1, the hypotenuse is 2, the longer leg, root 3. Okay, so if I want the exact values here, if I said exact values, for the sine of 120 is the sine of 60. Okay, the sine of 60 is root 3 over 2. That's the exact value. So the sine, let's do it right. The sine of 120 is root 3 over 2. Do it on your calculator, you'll get 0.866. If I don't ask you for exact values, you can give me 0.866. That's fine. Cosine of 120 is the adjacent side over the hypotenuse is 1 over 2. But hold on, okay? Hold on. This distance here is a negative distance. We're going to the left. Okay, this root 3 was positive because we were going up. But this distance is a negative. Okay, so if this is a negative, that has to be a negative 1/2. The hypotenuse is always positive. Okay, let's do tangent, and then we'll come back and discuss that. Tangent of 120 is the opposite over the adjacent, is root 3 over a negative 1, so that's a negative root 3. Okay? All right, now, if you're saying, what's all this about negative lengths, and I have to be careful now and watch out for negative signs? Yes, you do, okay? You have to be very careful, all right? And before I even go in that discussion, let's just check our work, okay? So we're going to find the sine of 120, and you get 0.866 rounded off, which is, here's the exact value, root 3 divided by 2, and that is 0.866. Cosine of 120 is negative 0.5. And that's what we got. Tangent of 120 is negative root 3. Negative root 3. Negative 1.732, which is the decimal for the square root of 3. Now, I have a little pet peeve with this whole negative sign business, okay? I always forget those. It's kind of a pain in the neck to remember how to get the negatives, how to get the positives. It's much easier if you use a little mathematical jingle, okay, that will help you remember whether your final answer should be negative or positive. And it goes like this, okay? A, S, T, C, okay? All students take calculus. If you can remember that little jingle, all students take calculus. In the first quadrant, all trig functions are positive. In the second quadrant, only the trig functions that start with a letter S are positive. Sine is positive in the second quadrant, okay? Now, if sine is positive, then cosecant would be positive also because it's a reciprocal. Take starts with the letter T. In the third quadrant, the only thing that is positive would be tangent. Tangent's negative here because it's in the second quadrant. But in the third, tangent is positive. And in the fourth, calculus starts with a C, so you know cosine is positive in the fourth. Okay? And in the fourth, sine and tangent would be negative. That's the easy way to remember. All students take calculus, and you can forget about worrying about, is this length positive or is that length negative? Okay? Much, much easier to do. Okay? All right. Now, we want to do the same for 135. Here we go. 135 comes over here. Draw your reference angle. If this is 135, this little guy here is 45. Okay? And let's find sine, cosine, and tangent of 135. With a 45, we know it's a 45, 45, 90 is 1, 1, root 2. So the sine of 135, darn it, the sine of 135 degrees is opposite over hypotenuse, 1 over root 2. All students take calculus, sine is positive. Cosine of 135, adjacent over hypotenuse, 1 over root 2. All students, cosine is negative. Tangent of 135 is 1 over 1. All students, tangent is negative. Okay? Easiest way there is to do it. How about 240 degrees? All right, here we go again. We're going to come, this time we have to come down here, right? Draw our reference triangle. You see how you draw the reference triangle? Always to the x-axis. We were up into this one, and we always drew it in the last two problems up in here. Here we have to draw it to the x-axis. It's going to look like that. If this is 240, then this over to here is 180, so this angle has to be 60. So it is a 30, 60, 90, which is 1, 2, root 3. Correct? Okay. Okay, so let's do sine, cosine, and tangent now of 240. Sine 240 is actually the sine of 60, opposite over hypotenuse, root 3 over 2. See it? All students take, sine starts with an S, negative. Cosine of 240. Adjacent over hypotenuse. Adjacent over hypotenuse is 1 over 2. All students take, cosine is negative. Tangent of 240. Opposite over adjacent. root 3 over 1. All students take stays positive. Okay? Now, gradient measure, pi over 4. Let's do it. Pi over 4, change it to degrees, 180 over pi, kill the pi's. 4 into 180 is going to be a 45-degree angle. So you have a negative 45-degree angle comes down here. Draw the reference triangle. Okay? Here's your negative 45. 45, 45, 90 is 1, 1, root 2. Agree? Okay? Here we go. Sine. Here's your reference angle, negative 45 right there. Sine of 45 is 1 over root 2. All students take calculus. Would be negative 1 over root 2 for sine. Cosine is adjacent over hypotenuse, 1 over root 2. All students take calculus, starts with the letter C, so cosine would be a positive 1 over root 2. Tangent is 1 over 1, opposite over adjacent, so tangent is 1. All students take calculus, tangent is negative. Okay? One more. 330, wow, that's a big one. 330 starts here, goes the whole way around like this. Draw your reference triangle. There's 360 in a whole revolution, so this little guy in here has got to be 30. Okay, there we go. 1, 2 on the hypotenuse, root 3 on the longer leg. Sine, cosine, and tangent. Sine, here's our reference angle in here, this little 30, if you can see it, little tiny angle in here. Sine of 30 is opposite over hypotenuse, is 1/2. All students take calculus. Nope, sine is negative 1/2. Sine of 330. How about the cosine of 330? Cosine would be the same as the cosine of 30, adjacent over hypotenuse, root 3 over 2. All students take calculus. Calculus starts with the letter C, so the cosine of 330, root 3 over 2, is positive. Tangent of 330. All students take calculus. We know tangent is going to be negative. Opposite over adjacent, 1 over root 3, negative. Okay? Okay, here are two trig IDs that are always true. Sine squared plus cosine squared will always equal 1. Tangent is equal to sine over cosine. Now, you can use those trig IDs. By the way, there's a lot more trig IDs than that. We're only going to do 2 of those. Those are the most important ones. So, can you write sine in terms of cosine? If you remember back to our discussion on the words in terms of, if I'm writing sine in terms of cosine, the only thing that can be in my explanation for what sine is a cosine. Okay? So, can you write sine in terms of cosine? Well, I'm going to pick this one. Let's start with sine squared plus cosine squared theta equals 1. I'm going to write sine in terms of cosine. So sine squared theta subtract cosine squared. Right? Okay. And now I don't want just sine. I don't want sine squared. So I'll take the square root of both sides. So sine theta is the square root 1 minus cosine squared theta. Can you all see that? Yeah, looking pretty good. Okay, now, but when you have x squared equals 25, x squared equals 25, isn't x equal to 5 or negative 5? So technically here, when I took the square roots, this could be the positive or negative square root. But it says theta is in quadrant 3. If theta comes the whole way around to quadrant 3, what is sine in quadrant 3? All students take. Sine is negative, okay? So if sine is negative, I don't want the positive square root. I want the negative square root. Watch out for that. How about writing tangent in terms of sine? All right, I know that tangent is sine over cosine. So tangent is sine over cosine. Now, in terms of sine, I can have nothing over here except sines. All right? So I got to get rid of this cosine. And I can do cosine just like I did here. Make it cosine squared equals 1 minus sine squared, take the square root. So this is going to be sine theta, same thing, square root 1 minus sine theta squared. Now let's see if we can get the sine correct, the SIGN, okay? Write tangent in terms of sine theta. It doesn't say where tangent is. If tangent is in the first quadrant or the third quadrant, all students take, first or third, it's going to be positive. Otherwise, it's going to be negative. Okay? So what we want to do is try to get both answers here. And it could be positive or negative, because I didn't tell you which quadrant it was in. Okay? And if you are in the first quadrant, sine would be positive. Okay, we want tangent to be positive, so you could have the positive down here. Positive. If you're in your second quadrant, this is positive. We would want the negative down here because tangent needs to be negative in the second. So it all depends upon which quadrant you are in, and I did not specify that. Okay, so it could be plus or minus. Okay, a couple more of these. Tangent of theta is 2/3 and theta is in quadrant 3. Find all the trig functions. Okay, here we go. We are in quadrant 3, so we're going to come down here. Yeah, quadrant 3. Draw your reference triangle. Now, the tangent of this big angle is the same as the tangent of this reference angle. And the tangent is the opposite over the adjacent. Opposite over adjacent is 2/3. And tangent is positive in quadrant 3. So we're good. Okay? Now, we want to find all trig functions. Well, I'm going to have to find a hypotenuse. So let's do Pythagoras. 3 squared is 9. 2 squared is 4. This is root 13. Yeah? Okay, so sine of theta should be opposite over hypotenuse, 2/√13. You can let the root 13 like that. All students take negative. Cosine of theta is adjacent over hypotenuse, is 3/√13. All students take negative. Tangent of theta, we know already, is 2/3 positive. Okay? How about the remaining 3 trig functions? Cotangent would be 3/2. Secant would be √13/3, and it's a negative fraction. It's got to stay negative. So negative √13/3. Cosecant, √13/-2, or negative √13/2. Okay, those are all the trig functions. Next one. Okay, we know that secant theta is 2, and we're in quadrant 4. Whoa! Go way over here. Draw your reference angle. So whatever angle this is, it's going to be our reference angle in there. Okay? Now, the secant is the reciprocal of cosine. So if the secant is 2/1, cosine would have to be 1/2. So cosine is adjacent over hypotenuse, 1/2. Do Pythagorean theorem. 4 minus 1 is 3. This is √3. Okay, 1, 2, √3. That's a 30, 60, 90 triangle, right? Okay, Let's find all the trig functions. So sine of theta would be the opposite over the hypotenuse, √3/2. All students take calculus, negative. Cosine of theta. Well, we can get that. We already talked about that. That's 1/2, and all students take calculus is positive. Tangent of theta is √3, the opposite over the adjacent, √3/1. All students take calculus, that's negative. Cotangent, -1/√3. Secant, 2/1. Cosecant, 2/-√3. Can you do those? Okay? Okay, find the area of the triangle. All right, so let me sketch it here. We have this angle is 72. This is 10. This side is 12. Do you remember the formula for the area of a triangle? Back in junior high school was 1/2 base times height. 1/2 base times height, base of 12. So 1/2 of 12. We need the height. We need the height. Yeah? And isn't the height the opposite side? There's a right triangle, the 72-degree angle, and a 10 on the hypotenuse. You can do sine. Sine of 72 degrees. Opposite over hypotenuse of 10. When I multiply, I'm going to get the answer immediately. So I'll take the sine of 72 equals, take it times 10, and I get the height is 9.51. There it is. 1/2 of 12 is 6. 6 times 9.51. And you have your answer. Final, I think this is the last problem. Find the blue area shown to the left. Oh, whoa, that's the right. Sorry. Sorry, slipped there. Find the blue area shown to the right. This is called a segment of a circle. The green area down here is called a sector. That's called a segment. All right, so let's take a look at this. All right, so we have a circle. We have an angle here. We have this blue region down here. I'm going to need a height in here. So I'm going to put a height right away. There. This angle then would be 60, 1/2 of 120. These radii are 24. Okay, so I need my height h, and I'm going to need that side x. Okay, hope everybody's with me so far. All right, so let's get started. Let's first find, just like this green area shows, let's first find the whole area here. The whole thing. Okay, can we do that? I think so. We did those before, called little to big. The little angle is 120. The whole angle, the whole way around, a revolution is 360. The little area of the whole thing is I don't know. The area of the whole circle I can get because I have the radius. So it is pi r squared, which would be 24 squared times pi. And I get 1808.64. Okay, so if the whole area is 1808.64, I want to cross multiply and solve to get just this region here. This is what I'm calling my x. Okay, so let's cross multiply. Times 120 equals, divided by 360 equals, and I get this region down here. This whole region here is 602.88. Now, if I can find the area of the triangle, that white region, I can subtract off of that and get just the blue. So I need to find this triangle. How do you find a triangle? 1/2 of the base is x. times the height. So I need X and H. I know this angle is 60. So what I want to do here is, if this is 24, I can get my X by doing the sine of 60. See it? Can you see it? Sine of 60 is opposite over hypotenuse. So sine of 60 is X over 24. Cosine of 60 is the adjacent over hypotenuse, H over 24. And I'll get my answers when I multiply straight, when I cross multiply. So I'm going to take sine of 60 equals times 24 and get X to be 20.78. Now my height, I'll do cosine of 60 equals times 24, and I get H is exactly 12, okay? So I want that times 20.78 is 249.36. There is the white area for that triangle. I'll subtract. And I get the area of just the blue is 353.52 square units, whatever they are, okay? Okay, homework. I've got another problem with a blue region that you're to find the radius of the circle, then some problems in the book.